Hi students, coming to our next topic, that is interrupt control IO. Actually, a data transfer between computer and IO can be done in three ways. So by using any of the three ways, we can transfer data between computers and IO. So those techniques are the programmed IO, interrupt control IO, and DMA. So these are the three different techniques that are used to transfer the data between computer and IO. Programmed IO, interrupt control IO, and the DMA, direct memory access. So we already discussed the programmed IO. So there is one disadvantage in using the programmed IO. Actually, the processor has to wait for a long time for IO module to send or receive of data. Okay, so in the programmed IO, the disadvantage is the CPU has to wait for IO module to send the data. Okay, so this is the disadvantage in programmed IO. So to overcome these disadvantages, we are going from interrupt controller. So in the interrupt controller, here the IO is used to overcome this disadvantages. We are going for interrupt controller. Here no repeated CPU checking of devices will be there. No waiting. Means the CPU does not wait for the IO module. It's do its own work. IO module interrupts CPUs whenever it is ready. Okay, so interrupt controller, no need to wait CPU for IO module. It can do its own work. So whenever the IO module is ready, then it interrupts CPU. Okay, so in the interrupt controller, the CPU sends a read command to the IO module. So and it does its own work. So whenever it is the IO module is ready to send the data, then it interrupts the CPU. So suppose if CPU is doing some work, if the interrupt occurs from the IO module, it stops its execution, it stop and save its execution and takes the interrupt request which comes from the IO module, do that operation. After the completion of that IO module request, it continues with the previous work. So with the help of this, there is no wastage of the CPU time. The CPU can do some other work until the IO module is interrupted. Okay, so here you can see, suppose this is a main program. Okay, this is the main program. So the CPU is working on this main program. 1, 2, 3 steps are going on. Suppose at the place of I, so at the ith place an interrupt occurs. Okay, so here you can I plus 1. Here the interrupt occurs. Means a call, suppose it is a function, a call is occur. So it goes to that interrupt program. So wherever it is there, interrupt handler. Okay, so it does those operations. After the completion of the interrupt handle, again the service goes to the main program. After the completion of the interrupt request, it goes to the main program and continue with the main program. So this is an interrupt occurs, means deviate the program. So whatever the operation it is doing, it stops that execution and goes to the interrupt service routine and take the interrupt request. After the completion of the interrupt, the CPU again return to its main program. Okay, so this is the interrupt controller by the IO device. Suppose this is the CPU, central processing unit. So it sends the interrupt request to the IO module. It sends the interrupt request to the IO system and does this work, do something else. It do something else. So whenever the system is ready, IO system is ready to send the data, it sends the acknowledge to the CPU. So I am ready, you just take my data. You just read my data. It's sending the signals to the CPU with the help of interrupt acknowledgement. Okay. So this is the way the CPU interacts with the IO module. Interrupt with the help of this interrupt. It's nothing but an interrupt controller. So here you can see the flow chart. So how the operations are going in between the CPU and the IO module with the help of this interrupt controller. So first what it does, it issues read command to IO module. So CPU first issuing read command to IO module and it is doing something else. Okay. So after issuing it, the CPU will work with his whatever work it is doing. Okay. So read status of IO module. So whenever the interrupt is occurred, from where this interrupt will occur? From peripheral devices. So from peripheral devices, the interrupt occurs. So then this IO module send the read status to the CPU. It is asking the CPU, okay, I'm ready to send the data. Just a signal is sending, interrupt signal to the CPU. So it checks the condition status. Which devices check the status? So CPU checks the status. If error condition maybe, it will quit the program. It discard that interrupt request. If no, it read word from IO module. Okay, the CPU check the status. The status is correct, means some device is waiting for to send the data. So interrupt is verified. So then IO word is it read word from IO module. So place that word in the CPU. So CPU read the data. So after reading, what the CPU will do? After doing the operation, it write word into memory, means saving the data. So CPU send that word to the memory. So write word into memory. CPU send that word to memory. So it's done. If it is over, it goes to the next instruction. If it is not over, again it goes to the starting point. If it is not done, again the CPU issues command to IO, read command to IO module. It do something else, and whenever the interrupt is occur, it read word from IO module and place it on the CPU. Then the CPU will write that word to the memory. So this is the process. How this is the internal process. Reading the command from IO module and placing the data in the memory. So how the CPU will read the word from IO module? Whenever it sends the interrupt signal to the CPU, then the CPU will take the data and write the data into memory. Thank you.